Hi there, welcome to the chemistry channel. Today we are going to talk about reaction, kinetics, and in particular about order of reaction. A general chemical reaction is written like this: between products, reactants, A reactant plus B reactant go into C plus D product. The stoichiometry of the reaction is, of course, given by the valence. And let's say for each products and reactants, I have particular stoichiometric coefficients, small a, small b, small c, and small d. In reaction writing, you typically write with one arrow if the reaction is reversible, and with a double arrow if the reaction is reversible. Now the speed of reaction is given by V. Now, depending on the reference that I take, that meaning whether I'm monitoring one of the reactants, the disappearance of one of the reactants, or the appearance of the product, I can write V, the velocity of reaction, as following. For example, we take and monitor A. Then VA, the speed of disappearance of reactant A, it's going to be minus the derivative of the concentration of A over time. The reason I took minus sign is because this reactant disappears with time. And this is then going to be equal to the reaction constant, typically the small k, times the concentration of reactant A to the power of the stoichiometric coefficient times the concentration of B to the power of the stoichiometric coefficient of B. So this is how you write a general reaction. On the other hand, you can measure the velocity, the speed of reaction with respect to the appearance of one of the reactants, or one of the products. So let's take, for example, C. Then the sign will be plus the concentration of C over dt, but this will not change. It's still going to be reaction constant to the power of A times the initial concentration of B to the power of B. So please note that in the first equation 1 and 2, in the first equation, I took square brackets as the concentration of the reactants. However, there's a slight difference between them, and that is in the right hand side is the initial concentration, so therefore we are going to add the subscript 0, and in the left hand side this is the concentration of the reactant with time, so therefore we are going to add a small t, just to, so the difference will be obvious. Next, we are going to learn about the order of reaction. The order of the reaction is given essentially by the sum. Let's label the order of reaction with n, and is given by the sum of the stoichiometric coefficients of the reactants A plus B. For a general reaction that involves a reaction between more regions, let's say A plus B plus C, with different stoichiometric coefficients A, B, and C, all small, the order of the reaction will be the sum of all the stoichiometric coefficients and so on. So that in practice we have different reaction types. If you take, for example, the decomposition of nitrogen pentoxide, which decomposes into NO2 plus oxygen, you would write the speed of reaction and as a K, reaction constant, times the concentration of the oxygen pentoxide. However, it's interesting to note that here the power of the initial concentration of nitrogen pentoxide, I took it as 1. The reason is that the decomposition is happening from a single molecule and not as a consequence of the collision of two molecules. So therefore we can rewrite the reaction as N2O5 decomposes into NO2 plus 1 over 2 times O2. That meaning that this is a simple decomposition reaction and it's sufficient one single molecule to produce this decomposition. I don't need two reactant molecules. So this is called a first order reaction. Another type of reaction is the reaction of hydrogen with bromine to produce HBr. That is bromic acid. Now, in order to balance the equation, we add the stoichiometric coefficient 2 here, and the speed of reaction, we are going to write it K times the hydrogen concentration times bromine concentration, and in theory the reaction order should be 2. In practice, however, N equals 1.5 for this reaction, and it can often happen that this is the case between theory and practice, and the reason for this is that the process involved of reaction involves more steps. We will come to that later. So this is a fractional order reaction. Another type of reaction is the reaction between two nitrogen dioxide molecules to give dinitrogen oxide product. For this, very straightforward to write, it's going to be the concentration of NO2 to the power of 2. So the reaction order is 2. In practice, this is also 2. So notice that I need two reactants, the collision of two NO2 molecules to produce one single molecule of N2O4. Another reaction resembles the one above and is the reaction between molecular hydrogen with iodine to produce two molecules of iodohydric acid, and the velocity of the reaction is this time written like this. We take the stoichiometric coefficients put into the power of each reactant concentration, and the reaction order is 2, and in practice this is also 2. Notice that number 4 reaction resemble very much number 2 reaction. The difference between these two is because this reaction is straightforward, doesn't involve more intermediate reaction to be produced. Let's take another. So this is a second order reaction. And let's take another reaction between two NO2 molecules, 4 hydrogen molecules, which results in nitrogen plus 4 water molecules, and the speed of reaction can be written as a concentration of NO2. Notice this here to the power of 1 times hydrogen to the power of 1. Again, this is not what it should be. In theory, I could write 2 and here 4. But such a reaction, such order of 6 is very unlikely, because then 6 would signify I need the collision of 6 molecules of reactants, and it's unrealistic. So every time when you meet such a situation, you have to question this, and even third order reactions as this one occur very seldomly. So for this we write it like this. So therefore this is a third order reaction. Next I will be talking about the mechanisms of reaction and how this mechanism, depending on how many intermediate steps will have, determine the reaction order, and will compare between the difference that we see in the theory and in praxis. And for that we will do a numerical example. So I'm looking forward to see you in my next video. Thanks for watching. Till next time. Bye bye.